So we're going to take some mass percent data and determine the empirical and molecular formula from that mass percent data. So caffeine has a molecular weight of 194.22 grams per mole. We will use that information later when we're determining the molecular formula. It's just there as a piece of information for right now. But caffeine contains 49.5% carbon, 5.2% hydrogen, 28.9% nitrogen, and 16.5% oxygen by mass. This is all mass data that we've been working with. So what is caffeine's empirical and molecular formulas? The most important thing for solving this mass percent data is to assume 100 grams of the compound. In doing that, all of these percentages, right there, become straight grams. So in 100 grams of the compound, if 49.5% of those of that 100 grams is carbon, that means that we have 49.5 grams of carbon, 5.2 grams of hydrogen, 28.9 grams of nitrogen, and 16.5 grams of oxygen. It's important to note that this is all by the element. We know that hydrogen is a diatomic molecule, but in these percents, we're not talking about hydrogen that you find in nature. We're just talking about elemental single atom hydrogen. So that's why we have H. Nitrogen is also a diatomic molecule, but in the mass percent data, we're just talking about N, not N2, and the same thing for the oxygen. Okay, in getting to the empirical formula, we have to convert these all to moles. So the atomic weight of carbon tells me that there's 12.01 grams of carbon in 1 mole. So the moles of carbon in this compound is 4.122. The atomic weight of hydrogen is that there's 1.01 grams of hydrogen in 1 mole. So that means that we have 5.149 moles of hydrogen. There's 14.01 grams of nitrogen in 1 mole of nitrogen. So we have 2.063 moles of nitrogen. And there's 16 grams of oxygen in 1 mole of oxygen. That gives us 1.031 moles of oxygen. All of these moles tell us the ratios to each other. So that means our empirical formula, before we simplify, is C, 4.122, H, 5.149, N, 2.063, and I'm running out of room, slide it on over, O, 1.031. We have to normalize all of these numbers. We have to make sure that they're in the ratio, the smallest whole number ratio. And in doing that, what we're going to do is divide by the lowest number. Our lowest number is our moles of oxygen. That's that 1.031. So we're going to take every single one of these subscripts and divide by the lowest number of 1.031. That gives us an empirical formula of C4H5N2O. This is the empirical formula. The empirical weight is what the molecular weight is for this compound. So 4 times 12.01 plus 5 times 1.01 plus 2 times 14.01 plus 1 times 16 gives us an empirical weight of 97.11 grams per mole. Again, is the empirical weight. Okay, now that we have the empirical weight and the empirical formula, we're ready to tackle the molecular. I'm telling you that the molecular weight is 194.22. We are going to take the molecular weight divided by the empirical weight. 194.22 divided by 97.11 gives us a ratio of 2. The molecular weight is twice that of the empirical weight. In order to make this into the molecular formula then, we take our empirical C4H5N2O and multiply everything in there by 2. So C4 times 2 gives us C8. H5 times 2 gives us H10. And 4O2. So the molecular formula of caffeine is C8, H10, and 4O2.